Friends who often time travel know that you can pick up anything on the journey. This time you conveniently picked up a piece of gold ore. So, how do you extract the gold from it? First, being accustomed to hard labor, you use a sledgehammer to smash the gold ore on an anvil until it's the size of soybeans. This is called ore crushing. Next, you transfer the crushed ore into a stone mortar and repeatedly pound it with a pestle. Then place it on a grindstone to grind it into a powder as fine as flour, fully exposing the gold particles. This is called ground ore. Then you put the ore powder into a gold pan, submerge it in water, and swirl, shake, and jostle it. Since gold is heavier than sand and gravel, under the flushing of water, the lighter gangue, sand and mud will be carried away by the water, while the heavier gold sinks to the bottom of the pan. Repeat this process until only a small amount of black sand mixed with gold remains in the pan. You've now obtained concentrate, also called gold dust. Congratulations, you've now obtained the concentrate, but it often contains heavy impurities like lead, copper, sulfur, and iron minerals, which require further clarification. So you mix the concentrate with metallic lead in a ratio of roughly 1 part ore to 4 parts lead, place it in a crucible, and put the crucible into an ancient-style furnace, using charcoal as fuel to heat it. Lead has a melting point of 327 degrees Celsius, so it melts first, and like a magnet, dissolves the dispersed gold and silver, forming a gold-silver-lead alloy that sinks to the bottom of the crucible. Other impurities that don't react with lead float to the surface, forming slag. After skimming off the slag, you obtain a block of impure alloy ingot. This is called sintering. Finally, the most important step. You need to oxidize and remove the lead and other impurities from the alloy to purify the gold and silver. You take a large amount of animal bone ash, press it into a porous shallow bed with a groove dug in the center. Place the sintered gold-silver-lead alloy ingot into the groove of the ash bed. Surround it with charcoal to form a cage, and then continuously blow air while heating to keep the alloy in a molten state. The air from the blower oxidizes the molten lead, generating lead oxide, known as litharge, and the liquid lead oxide, due to its weight and fluidity, is completely absorbed by the porous bone ash bed like a sponge, or blown to the edges as slag. As for gold, because of its stable nature, it withstands fire and is not oxidized. You continue blowing air at high temperature until the lead is completely blown out, and the bone ash no longer absorbs lead oxide. At this point, what remains on the ash bed is a glowing, bright, high-purity gold-silver alloy. Congratulations! You've now learned the ancient gold refining technique known as the cupellation method.